Hello again, welcome to my channel. Today I'm talking about linear motion where two vehicles are moving in the same direction. We're going to apply rules of relative speed where two vehicles, if they are moving in the same direction, the relative speed is obtained by subtracting the two individual speeds. Now we have a car and a bus. Both of them are coming from one point, let's say point A, and they're all going to point B. Now the speed of the car is 100 kilometers per hour and the speed of the bus is 80 kilometers per hour. Let's take a look at the car start earlier to the journey at 10 a.m. and let the bus start the journey at 10:30 a.m. meaning the car started the journey earlier than the bus, and the time taken for the car to move before the bus started moving is actually 30 minutes, because the car started at 10 a.m. and the bus started later at 10:30 a.m. so the bus is late with 30 minutes. So the car is moving to point B or to the right. At the same time, at 10:30 the bus will also move to the right hand side, which is at point B. Now the distance between the two towns, which is A and B, is 500 kilometers, and the two vehicles are going to move to town B and both of them will cover 500 kilometers. But here we have a case where the car started moving earlier than the bus. So the speed of the car is 100 kilometers per hour and it is going to start at 10 a.m. So from 10 a.m. to 10:30 the car, as you can see on the screen, will have covered a certain distance. So the car will have covered a certain distance in the 30 minutes before the bus began its journey. So the bus will begin its journey at 10:30 a.m. Now before 10:30 a.m. the car had covered a distance for those 30 minutes. We need to calculate the distance covered in those 30 minutes. Remember, it is the car which started moving earlier and it is the only one which is moving. Therefore, we will have to use its speed to calculate the distance. So the formula of distance, so as you can see on the diagram, we said initially the car started 10 a.m. and as you can see, by the time when it is 10:30 a.m. the car will have covered a certain distance which is covered in the 30 minutes before the bus. Now the distance covered by the car before the bus, we know the formula is speed times time. So time taken by the car before the bus started, we all know the bus started at 10:30 and the car started earlier at 10 a.m. So we take 10:30 minus 10 a.m. we obtain 30 minutes, which is the time where the car was traveling before the bus, and we get either 30 minutes or a half an hour. If we calculate the distance, we say distance covered by the car before the bus is equal to 100 kilometers per hour times 30 over 60 hours, which we obtain 50 kilometers. Therefore, the car had covered 50 kilometers before the bus started moving. So the distance between the car and the bus after 30 minutes is 50 kilometers. There we go. As you can see now, the distance between now the car and the bus is 50 kilometers. The car is ahead of the bus with 50 kilometers. The bus is moving at 80 kilometers per hour, and at 10:30 a.m. now both the bus and the car are moving in the same direction, and because both of them are moving, the distance between the car and the bus is now the 50 kilometers. So what do? It means the bus has to move such that it has to move to cover 50 kilometers for it to catch up with the car. The car at the same time is traveling at 100 kilometers per hour. So the two vehicles, because they're all moving now from 10:30 a.m., we use the concept of relative speed. Whenever two vehicles are moving in the same direction, the relative speed of the two vehicles is just subtract the two speeds. So in this case, we will take 100 kilometers per hour minus 80 kilometers per hour. So when you subtract together that, the two vehicles are moving with a relative speed of 20 kilometers per hour. Okay, now as you can see there, at 10:30 a.m. both the car and the bus will all be moving towards the same direction, and the distance between them will be 50 kilometers. So as they are moving, the bus will have to cover the 50 kilometers for it to catch up with the bus. Now the time taken for them to meet, because they are now all moving, the time taken for them to meet or to catch up with each other can be calculated as follows. So before we go to the calculations, let's see. The car is moving at 100 kilometers per hour, and the bus is also moving at 80 kilometers per hour, and both of them are moving towards the same direction, and both are moving, and they all started moving together at 10:30 a.m. So remember, the car is moving also with its own speed of 100 kilometers, and the bus will also move with 80 kilometers per hour, and they will catch up somewhere. So as you can see on the screen, the point where the two vehicles will meet is actually shown on the screen. If you want to find the time taken to the point where they met, that is the distance between the vehicle, the time taken for them to meet, you will just say the distance between the vehicles and over the relative speed of the two vehicles. Now the distance between the two vehicles for this case is actually 50 kilometers, because the bus has to cover the 50 kilometers for it to catch up with the car. Now going down the screen, as you can see, distance, time taken rather, is given by distance, which is 50 kilometers between the cars and the bus, over the relative speed, which is 100 kilometers minus 80 kilometers, because the two vehicles are moving in the same direction. Therefore we come and obtain 50 divided by 20 kilometers per hour, we obtain 2.5 hours. So 2.5 hours will be the time taken for them to meet. So let's find the real time, actually in the PM or AM, where the two vehicles met. We've used the formula. Time taken to meet is actually, we have seen, it is 2.5 hours. We add that time to 10:30 a.m. because that's the time where the bus and the car were all moving. Alright, we cannot take 10 a.m. because at 10 a.m. the bus was not moving. Therefore, when you add the 2.5 hours to 10:30 a.m., we actually get the car and the bus are going to meet at 1 p.m. So 1 p.m. it is the point where the two vehicles are going to meet. So we can illustrate using the two vehicles here. The car is moving at 100 kilometers per hour, and from 10:30 both of them are moving. So the car was moving and it is ahead, as you can see, and at the same time from 10:30 even also the bus is moving. So as you can see, they're going to catch up somewhere. So at what time are they going to catch up? We have found that it is 1 p.m. So 1 p.m. is the point where the two vehicles are going to meet.